Today we're going to talk about solving linear systems by substitution. Now what you already did is you solved them by using the graphing method, using your calculator. And now what we want to do, we have several ways that we need to be able to solve systems. The next way that we're going to do it is by using what we call substitution. Okay, so you can do this without a graphing calculator, believe it or not, and be able to figure it out as well. So when we want to use substitution to solve, okay, we want to solve one equation for one variable. So we're going to solve for either x or y or whichever variable that we're given. That's our step one. Step two is to substitute. That's why we call it the substitution method. Substitute the resulting expression from step one into the other equation. Step three is to substitute the value that you get from step two into either equation and solve for the other variable. So, and that's how we'll get our ordered pair. So going ahead, an example that was given to us was y equals 2x plus 1, and then 3x plus y equals -9. See how this first equation, it's already solved for y, so it says y equals 2x plus 1. If y equals 2x plus 1, we can use that and substitute it into the second equation. And that's exactly what this example is showing us. If 3x plus y equals -9, that's the second equation. Well, now we're saying y is 2x plus 1. So 3x plus 2x plus 1 equals -9. All right, see how they took that and substituted it into the equation. Now all you have to do is solve for x. Once you do that and you find out that x equals -2, all right, just plain and simply doing the math, then you can go ahead and substitute that x into either equation, all right? It just so happens that this example chose the first equation, and so it substituted that -2 in for x. So 2 times -2 plus 1, and you get 3. So your solution is -2, 3. -2, -3. And then you can graph it and check it and make sure it's okay. So you will need to know this method. Some of you might be saying, well, it's so easy just to put it on the calculator. Why do I have to do this? All right, well, there will be questions that will ask you specifically how to substitute and how to show your work by substituting on your test as well as on an SOL. So, isolate y, all right? Here all we're doing is we're actually just practicing how to isolate y, all right? This is kind of when we talked about literal equations. Some of us are still having issues with that. So here, y is going to equal -5x minus 8. For this one, it says isolate x. Now, you see what we're doing is we're choosing, all right? We're looking at the problem, and it would be silly to isolate or to solve for y here when we're using the substitution method because x is already by itself. Okay, so you actually have to look at it, assess what you're going to do, and then go from there. So here we have x equals -3y plus 7. And then finally here, to isolate for y, we have -3y equals 3x plus 9. So it'd be y equals -x minus 3. All right. If you have questions about that, please write it in this section here and we'll talk about it. All right, preliminary step to solving by substitution. Before we do anything else, all I want you to do here is to assess these problems and decide which one of these equations you would isolate the variable for, okay? So For example, all I want you to do for this, I don't want you to solve it by using substitution. I want you to just look at, for here, number 4, I'm looking at it and I'm saying, well, I would probably isolate the y. I would choose this one to isolate the variable in order to solve. It doesn't require a lot of steps, which in turn means that there's probably less chance of me making a mistake when I'm solving for that variable. All right, so go ahead and make your choice for number 5 and 6, and we'll talk about those in class. All right, so let's go ahead and take a look at this second page. Okay, so for number 7, it says solve the following systems of equations by using substitution. Check the solution algebraically. Okay, so what we're going to do here is, well, number 7 has kind of done it for us. That was kind of nice of them. So for number 7, it says y equals x plus 3. So what I'm going to do is I'm going to substitute this into this equation where it says y. So it's going to be 3x minus x plus 3 equals 5. Okay? Now, why did I put that x plus 3 in parentheses? All right, that's the entire value of y. And with that negative sign there, I need to rewrite this as 3x minus x minus 3 equals 5. Now I can go ahead and solve for my x by saying 2x equals 8. All right, I added 3 to the 5, so I got rid of the 5 and combined my x's. And x equals 4. So now I'm going to go ahead and take that x and substitute it in, and it says y equals x plus 3. So it's going to be 4 plus 3. So y equals 7. All right, so right now I have 4, 7. Doesn't seem as though I have a lot of room to check, but what I want to do is I want to take that 4 and 7. It says check their solution algebraically. Absolutely, you can go ahead and graph these and check it that way. Another way we can do it is take 4 and 7 and see if they meet the needs of both equations, and that's what I'm going to do. So for this one, I have 7. I'm substituting in my values. 7 equals 4 plus 3. And sure enough, we should know 4 plus 3 equals 7, so that checks. Here I have 3 times 4 minus 7 equals 5. 12 minus 7, sure enough, equals 5. So that one checks out as well. Okay, so let me get you started for number 8. All right, what I would do is I would go ahead and I would solve for x here. So x is going to equal 3. So go ahead, substitute it in, find out what our x value is, and we'll even start with this. Find out what your y value is and check your solution. Please do that for 9 as well. We'll talk about those in class. What I want to do down here is we want to do the exact same thing on 10, 11, and 12. The only difference with these is it just kind of kicked it up a notch, okay? Up here, it's kind of simple. It's kind of done for us to isolate the variable and to solve for the variable. Down here is where we need to go ahead and look at these problems and say, okay, what do I want to actually isolate and solve for? For number 10, what I would do is I would solve for x in the first equation. And I would go ahead and say x equals, and it would be y plus 10. or 10 plus y, of course, the commutative property. It doesn't really matter what order that's in. So now I'm going to go ahead and say 5 times y plus 10 minus y equals -6. I've substituted this into this equation for my x variable. So now I have 5y plus 50 minus y equals -6. So 5y minus y, that's 4y, equals -50 plus -6 is -56. And y is going to equal, we'll say 14. Let me make sure I'm right. -14. I knew the negative was there. I just wanted to make sure the 14 was right. So now I have my y, all right? So there's my comma. I have -14 as my y. And let's see. I can go ahead and substitute this in. And I'm going to go ahead. I'm going to erase this up here. Well, I have room to check down below on this problem. So let's see. I'm going to say x minus -14 equals 10. Okay, so I have x. I want to solve for minus -14. So that's going to be plus -14. Add -14. This cancels, and I'm left with x equaling -4. So I have -4, 14, solving for my x value. Now, let's go ahead and check this. Let's see. Starting up here with the first equation, I have -4 minus -14. Does that equal 10? -4 minus -14 is 10. So 10 equals 10. That checks out. 5 times -4. 5 times -4 minus my y value minus -14 equals -6. So 5 times -4 is -20. Minus -14, that's like saying plus 14. And -20 plus 14 most certainly does equal -6. Try and solve 11 and 12 on your own, and we'll go ahead and we'll talk about these problems in class. Thank you.